Okay, I'm just wrapping up this last question in 8.1 and then we're moving on to 8.4. So for this one, remember that what we were doing was we were getting theta. So we were figuring out, okay, tangent of theta is y over x. The 3's cancel. In other words, where is tangent theta equal to negative square root of 3? We got the arctangent of both sides, and so we're seeing in the unit circle, where are we getting tangent of negative square root of 3? Okay, so we figured out that it could be 2 pi over 3 or 5 pi over 3, but because this original coordinate, rectangular coordinate that they gave me is in the second quadrant, because x is negative and y is positive, we're going to be able to only go with the second quadrant angle. So that is why the answer is 6 comma 2 pi over 3. Okay, so we're done with that. Now we're moving on to vectors. That's always fun. Okay, again, we're doing elementary type vectors, like the very useful things to know, including word problems. So we're not diving that deep. We want to dive deeper. Calculus 3 is the place for you. So 8.4 vectors. Okay, number 1. Number 1 says vector v extends from 0, 0 to 3, 4. Vector w, negative 2, 3 to negative 5, negative 1. Find the magnitude. So we talked about it in class when they gave us 2 ordered pairs, and you need to find the magnitude or the distance, the length, the force, right? Whatever the context is behind it. So magnitude of v and magnitude of w, we're going to use the distance formula. So remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so because they give us 2 ordered pairs, you just simply plug in, right? So when you plug in, you can check yourself, right? So for v, they give us 0, 0 as its first ordered pair, right? Where it starts. And then its endpoint is 3, 4. So that's our second order pair, right? So you just simply plug in. So that's going to be 3 squared plus 4 squared. Okay, so that's 9 plus 16, which is the square root of 25, which is 5. Okay, for the bottom one, same concept, plug in your values. And you can check yourself, but you should get negative 5 minus negative 2 squared and negative 1 minus 3 squared. Okay, so that's negative 3 squared, which is 9, and then negative 4 squared, which is 16. Okay, so you're getting the same magnitude for these vectors. So for part A, they're both 5. Again, in the notation is these double lines for magnitude. The second question is, are they equal? And the answer is no, they're not. They're in opposite directions. If you want to visualize it so you can draw. So for v, we're starting at 0, 0, which is the origin, and we're going to 3, 4. Initial point, terminal point, right? It's a line segment, and then you put the arrow to show the direction it's going in. Where this is v, vector v, and vector w, I'll give it a different color, starting at negative 2, 3. And it's going towards negative 5, 1. Negative 5, negative 1. So as you can see, no, they're not the same vectors, because remember, to be the same vectors, you need to have the same magnitude and the same direction. And right now, they are going in opposite directions, so they are not the same. Okay, of course, you would prove it by drawing it and seeing the direction that they go in based on the terminal, the starting point and the terminal point. Part 2, suppose that the vector has initial point, starting point, find the component form. So we talked about how useful the component form is, or the component vector, when we're talking about vectors. Why? Because a component vector makes it start at 0, 0. Okay? So, and it's written in this notation. Okay, component vector. Okay, so again, plug and chug type of thing. So we have our initial point where the vector starts, and we have the terminal point, -1, 12. Okay, so label them. Ordered pairs are always x, y. Since you have more than one ordered pair, we'll call the first one x1, y1, second one x2, y2. Simply plug in. So it's going to be x2 minus x1 and y2 minus y1. Therefore, we're getting -3, 7. Okay, in vector, 3. -1 plus 4 is 3. 3, 7 vector notation, right? See, so what does this mean? We've drawn these before, so this means that you can actually find 3, 7. And that is the terminal point, and you're going to start from the origin. Okay, so that's a way to also move your vector into good positions, which it's always good to be in starting position, meaning that your start point is the origin. Okay, that's what the component vector is useful for. Okay, so once we find the component vector, that's part A, we can do the second part that it's asking us for. This is part A. Part B is asking us, hey, if V is placed with initial point somewhere else, what would the terminal point be? Okay, so if the initial point, we've done this in class, as long as you were there. Initial point, let's say now I want it to be at -2, -4 instead of 0, 0. Okay, then where would the terminal point go? Okay, so what we do is we use the component vector to do that. Okay, so remember we're just simply shifting it. So instead of going from 0, 0 to 3, 7, we're going from -2, -4 to its new terminal point. So how do we figure out that terminal point? Remember, it's an ordered pair. Okay, so we're going to start with the initial point, and we're going to add the component vector and its corresponding area. Okay, so this is going to give us 1, 3. Okay, so now this is where the vector is gonna end. Okay, it's just been shifted. This is the correct way to shift. First, you find the component vector, then you simply use the component vector and your initial point to see up to where it'll go. Okay, good questions. Good questions. Okay, 4 is super simple. These are all really good questions. 8.4 is my favorite out of this practice exam. I think it's very straightforward, as long as you know what you're doing and the concept behind it. So now it just says, hey, we have component vectors. Can you do some algebra? Oh yes, of course. So for number 4, I'm only gonna do one of them. For 6a, that just means you have to multiply 6 with your vector A, component vector. Okay, A. So I guess I'll do it. So that's 66, -42. Super simple. Cool. For part B, it's going to be -3 times A plus 10 times B. And this is kind of similar to the matrices in the sense that you're just completing the operations. But it's not like a lot changes except the coefficients. Let's see, it's negative 39. Okay, perfect. Again, plug in. Okay, so we're moving on to number 5, which is the unit vector. Okay, remember for unit vector, you're finding a vector in the same direction but with a magnitude of 1. So we're purposely going to make it have a magnitude of 1. How do we do that? We start off with what they give us. This is skill practice number 5 in 8.4, which is vectors. Okay, so we're starting off with 5, -1. Okay, and we're trying to find the unit vector. Okay, so the unit vector is 1 over the magnitude of v times v. Okay, so let's figure out what the magnitude of v is. Remember that when you have the initial point and the terminal point of the vector, you're going to use the distance formula to find the magnitude. But once you have it as a component vector already, that means that it has been shifted and now it's starting at the origin and it's going to this point, 5, -1. Okay, so if we want to draw it, to visualize it, this is what it's doing. Starting at the origin, going to 5, -1, we're trying to find a unit vector UV, vector V, that only has a magnitude or length of 1. Okay, so with that being said, let's find the magnitude. So what do? We've talked about this before. You can call this A and this one B. We're doing A squared plus B squared. Okay, so it's going to be 5 squared plus -1 squared, which is 25 plus 1, which is 26. Try to simplify it if possible. Can't simplify that. So it's the square root of 26. So I'm going to go ahead and plug it in now. This is a formula. So it's going to be 1 over the square root of 26. Why are we doing this? Because if I want the magnitude to be 1, and the magnitude right now is the square root of 26, well, if I divide the square root of 26 by itself, I'll get 1. So this is the concept behind this. So if I divide, if I divide by the square root of 26, now I'm forcing it to be magnitude of 1, okay? So we're going to go ahead and we're going to multiply our vector v with the 1 over the square root of 26, okay? And again, you don't have to rationalize the denominator. You are allowed to leave it like that. Okay, so that's it. Again, Khan Academy has great examples. But you're going to use the fact that you're going to get the magnitude. If the magnitude is not 1, which most of the time it's not 1, it's longer than that, or shorter than that, then you're going to go ahead and you're going to divide by that magnitude on purpose to make that unit vector have a magnitude of 1. Okay, so done with that. Now we're moving on to the last 2 questions, which are the best questions ever. We have the word problems. So now we have a person, it's late. A person exerts a force of 80 pounds. Okay, so is exerting a force, which is magnitude, right? Force of 80 pounds on an object by pulling on a rope at an angle of 30 degrees from the horizontal. So pulling on a rope, and it's 30 degrees from the horizontal, which is a straight line. Write the force vector F in terms of I and J. So a person's hand. I can't really, not the best at drawing, but here. The person is pulling the rope at this 30-degree angle from the horizontal. Okay, so we're trying to find the force. So force, remember, is going to be, the force vector is going to be the magnitude of F times cosine theta I plus magnitude of F times sine theta J. Remember we talked about I and J in class? I is 1, 0, and J is 0, 1. And of course we know that X is cosine and Y is sine. Okay, so that you can go back and see the proof of the formula. Okay, now we have the magnitude. So all we need to do is find the angle. Okay, so let me see. Okay, so we have here 30 degrees. Now remember that it's always calculated counterclockwise. So since this is a first degree angle and we're going counterclockwise from the x-axis, the right side of the x-axis, then it stays as 30 degrees. Okay, remember that in the next one you'll see that you want to, if it's further down, you want to continue and find that complete angle, right? Counterclockwise. So here we actually get to use the 30 degrees since it's already counterclockwise, and that's all we have. So that's 30 degrees is seen as 30 degrees in the first quadrant, essentially. So 30 degrees, that's the same as pi over 6. That's the square root of 3 over 2 for x and 1/2 for y. So we're going to plug in. So cosine of 30 is the square root of 3 over 2. Don't forget times 80. And then sine of 30 is 1/2. So it's 80 times 1/2 j. So this force vector is, at least we can simplify 80 and 2, right? So 80 divided by 2 is 40. So it's 40 square root of 3i plus 80 divided by 2, another 40j. And this is the force vector in terms of I and j. Okay, good. Feel free to pause, rewatch it, look at your textbook. Right, and then last but not least, we have our beautiful problem. I wish we could have done the static equilibrium one, but this one's really good too. This is 3 forces acted upon. So this is, let me draw it for you. Force, oops, this is force 1, force 2, and force 3. Okay, all right, cool. So it's saying if the magnitude of F1 is 32 pounds, if the magnitude of F2 is 24 pounds, and if the magnitude of F3 is 15 pounds, can you find the resultant force? Remember that resultant force R is you adding up all the forces. As many forces as possible, or as that's going on as part of your problem, you're going to be adding them. Okay, so let's go ahead and see if we can do this. So we're going to have 3 force vectors. We're going to have force 1 vector, force 2 vector, and force 3 vector. Okay, so again, we know the formula. It's going to be the magnitude times cosine theta I plus magnitude sine theta j. Okay, and so on and so forth. Okay. So we need to figure out the correct thetas, right? The correct angles. So for force 1, it is right on the 90 degrees. Okay, so that'll be nice. We can plug in 90 degrees. I already know that force 1 is 32, so I'm going to plug that in as well. the second one, again, it's counterclockwise. I have the 90 degree, and then I have another 68 degrees to get to force 2. So that's 90 degrees plus 68 degrees, which is 158 degrees for my theta force 2. That's 158 degrees. Okay, and of course I know what my force 2 is 24, so I'm going to plug into the formula. For force 3, the magnitude is 15, and let's figure out if we can figure out that theta. So for force 3, again, you have to go all the way counterclockwise, so it's going to be all of this, all of this, all the way to here. So as you can see, it's everything, almost the whole unit circle, but with a difference of 40 degrees. So 306 degrees is the whole unit circle, minus the 40 degrees in order for us to go counterclockwise until we get to F3 is going to be 320 degrees. Okay, so we're going to plug in 320 degrees. Now, of course, if the angle is in the unit circle, then go ahead and use the unit circle. But if it's not, then you just plug in to the calculator, and we're plugging in degrees. Okay, so at least we can solve the first one. The first one, we have 0, 1 as the coordinate and 90 degrees. So the x value is 0. So the cosine is going to go away. And then the y value or the sine is 1. So sine of 90 is simply 1. So this is just going to be 32 times j for force 1. For force 2 and force 3, you're going to have to plug into the calculator and get your answers. So I already did that for you. Okay, you could check your work. This is going to be, where did it go? Here. It's negative 22.25 for I plus 8.99 for j when you plug into the calculator. First, of course, figure out the sine or cosine of the angle is, then multiply by the number, keep your I, keep your j. For F3, when you plug in, you're getting 11.49 I minus 9.64 j. Okay, so I have my i's and my j's for each force vector. And now I need the resultant force vector, which is all of them added together. So of course, join your like terms. We have i's, we have j's. So when you join your i's, okay, that's, let me use a different marker. Resultant force is all of them added together. Okay, and now of course you can only put your like terms together. So let's go ahead and do negative 22.25 I plus 11.49 I. Right, you could do the math on the side. Okay, but this is negative 10.8 I. And then of course you can get your j's together. So you're going to do your 32j plus your 8.99j minus your 9.64. I'll just do it here. I got 31.35. Okay. If you use my numbers, I think I got one more decimal here. I can check it really quickly since I'm not using a physical calculator right now. So this is, let me just check it really quick. I'm pretty sure I got another decimal point. Okay, so obviously it's negative, so I'm gonna subtract. Okay, got negative 10.76. Okay, and that's our answer. Okay, the book got negative 10.8i plus 31.3j. So we did even better, and we got 2 decimal places, which is the hundredths place, and we got the correct resultant force vector. Okay, so I hope you studied, you enjoyed, you learned something. Keep it up, and see you on Thursday for your exam.